So welcome to everyone. Today we are going to discuss something called functions with C. So functions are the important elements of any programming language, and you can say that functions are the group of statements that together perform a task. And the main advantages of a function is to we can avoid repeated coding. For example, if I want to do some repeated task, instead of writing the code again and again, we can put it into a function and then we can call whenever we need it. So it increases the readability of the code also. So you know that because C is a kind of procedure oriented programming, so here we are going to divide this into different modules or a function. So each and every module or a function can take a part of the code. So mainly you can say that functions break the large computing task into smaller ones. So mainly we are using is to reduce the size of the code. So you know that every C program will have a main function. So main is the one type of user defined function. So every C program will have at least one function which is called as main. So it depends on the complexity of the application, the number of functions differs. And again I'm repeating, depends on the complexity of the task, the number of functions differs. For a task we can have one function, two functions, or 10 or n. So whatever we want we can include it. So we have two major types of functions, like predefined function or library function and user defined function. In terms of predefined functions, the code will be there from library itself. Simply by calling them we can use it, but no need to write the code for it. But in terms of user defined function, we have to create the function, that is we have to write the code for the function, then we have to use it. And if we are using predefined functions or library functions, we have to import the corresponding header file. You may remember, like in strings we have used strlen, strcpy, strcat and all. So all those functions are called as library functions. So we have included a header file called has include string.h for those applications, right? Similarly, each and every library function will have its own header. For user defined function, we have to write and we have to call, and all the tasks we have to explicitly do it. So before going to it, I'll go with a simple example that will tell you the use of a function. For example, and there is no logic behind this code, just it will tell you what the use of it. For example, if I want to print something, if I'm printing as testing, okay, if I'm printing as test1, test2 and test3. Say for example, after sometimes I want to do the same task. So and imagine some code we have in between. So after sometimes I want to repeat the same task, what we will do it again, we will type the code. After sometimes I want to do the same task, again we will write the same code, right? So imagine this is the code. Now and the file name is example1.c, and now I'm going to run the code, that is gcc space example1.c. it is what happened. Okay, I gave us print instead of printf, right? Okay, fine. Let me correct it. So here we are imagining that we are going to do this task for 3 times. Okay. So there is no error. I'm going to run the code. Okay, something like test1, test2, test3, again it is happening, right? So, and instead of writing the code again and again, what I'm planning to do is I'm going to put it into a function. So like in terms of function, 3 major things we have. You have to declare the function, you have to define the function, and you have to call the functions, right? So I'll tell you what is what in the next examples. I'm declaring a function called a task, something like task of. Then I'm going to define it outside of main. So inside this I'm going to put the task, like printing test1, test2 and test3. So this is a task I'm giving inside a method function called task. So whenever I want to do this particular task, instead of writing the code, I can call this function. So here I want to perform the task, I can give as task of. Okay, after sometimes I want to perform, okay, let me run this. So gcc example2.c. So it is printing something, right? After sometimes I want to perform the same task. So instead of writing the same code, simply I can call the same function called task of. So see to it. Here I'm not writing the same code again. So simply I'm going to call the same function. So I'm going to compile the code. No error. I'm going to run the code again. So we got it for twice, right? If I want to perform the same task after some time, again simply I can call the same function. So instead of writing the code again and again, what I'm using, so I'm defining it into a function. So whenever I need, I'm going to call it. So this is called as function call, this is called as function definition, and this is function declaration. I'll tell you what is what. Wait. So now instead of, and see here the number of lines of code is more. Here the number of lines of code is less. The one advantage is you can reduce the number of lines of code, and that is size of program we are going to reduce it, and which increase the readability of code. So we'll proceed with the PPT. So this is an example, and there I have I gave a function name as task, right? Here it is so this is function declaration and function call and function definition. I'll tell you what is what. So there are some elements like we have function prototype, which is otherwise called as function declaration, function call, function definition, actual arguments, formal arguments, and return. We'll see one by one. So before, okay, we'll see one example first, then we'll go for it. So we are writing the code for addition of two numbers. So normally how we used to perform addition of two numbers, inside main we used to read two numbers and we will perform the addition of two numbers, print the result and same thing, right? Now I'm using functions for adding two numbers. So we are going to include header file and main. So I'm declaring two variables called a as well as b. I am declaring a function. So what is the need for function? You know, if as per the rules of C, C++ programming, all the variables or all the user-defined elements should be declared before it is used. In scanf, if I'm giving as ampersand a, which means what? I'm going to read the value for a. So I should declare the variable before. Similarly, the same rule applies for a function also. So similar to variable, all the functions must be declared before it is used. So, and this is what function declaration. So what is the meaning of this statement? So here I'm telling that there is a function called add, which takes any two integer arguments, which returns nothing. You know that void is also data type, and void stands for nothing. So here we are going to say that there is a function called add, which take any two integer as parameter and which returns nothing. So here we are using as void, here we are using as int. What is the difference actually, that I'll tell you. Okay, so we are declaring a function. So here always add will work only with two integer inputs. Then as usual we are going to read values of a as well as b, and now I'm going to call the function. So what is the function name? Add. And what are the arguments we have? A as well as b. So I'm going to define the function outside of main. Okay, one more thing here. Okay, I'll tell you that. So here we are calling a function, we are defining it outside of main. So what we are calling the function call add. How many inputs we are passing? Two inputs. What type of inputs we are passing? Integers. So as we are passing two integers here, we have to receive two integers. That is, I'm passing a as well as b, and I need two more variables to store it. So a will go to x and b will go to y. So here whether both ab and xy will be with same address? No, it is a different address. Here ab is a local variable to main. So the availability of local variable ab is only within this main. After main, compiler will have no idea that what is a and what is b. So I'm copying a to x and b to y, and inside we are going to write the code for addition of two numbers, then we are going to close it. So in terms of function declaration, we are declaring it, and whenever we need, we can call the function. We are going to define it outside of the main. So how many times we have to declare, how many times we have to call, how many times we have to define? Only once we have to declare, and only once we have to define. But we can call n number of times. Whenever we want to perform the task, we can call the function. But there is but in terms of declaration and definition, we can do only once. One more thing, what is AB and what is XY? So AB is local to main function and XY is a local to add function. So AB will have a separate memory address and XY will have a separate memory address. So actually we have the inputs in terms of AB, and A we are going to copy into X, and B we are going to copy into Y. We are going to perform the operations on XY, not with AB. So actually we have inputs in terms of AB, and AB are called as actual argument, the actual inputs we have in terms of AB. But XY are called as formal arguments. So formal arguments, you can say that the photocopies of actual arguments. There are Xerox copies of actual arguments, you can say that formal argument. So all the tasks we are going to do only with formal arguments. Actual arguments, we have received the input and we kept as it is, that's it. Okay, and you can say that actual arguments are the arguments used with the function call, and formal arguments, you can say that the arguments used with the function definition. Okay, if I want to perform the addition of two numbers again, what I can do, I can read two more inputs and I can call the function called add of so and so. Okay, one more thing. So whether it is compulsory to go for functions for addition of two numbers, because instead of going for this much number of lines, I can write the code as printf. Here I can write the code as printf percentage d comma a plus b, right? Why it is required? So this is a simple example in that we are learning how to use it. For example, if you want to check a number as prime number, so the number of lines of code will go for more than 10 lines, right? If you want to calculate a number as prime number in 5 places in a program, so you will write that code for 5 times. It will go for 50 lines. So instead what we are going to do it, we are going to write the code for calculation inside the function, and we can call it whenever we want to check it. That is the advantage of it. This is a simple example. With this we are going to learn how to use it, that's it. So for addition of two numbers, functions are not efficient actually. So now we'll go to it. So what are the function prototype? I'll explain with the help of that example. So if I'm giving as void swap of int comma n, this is called as function declaration. So what is the syntax? Return type, function name, and argument list. So instead of void, is it possible for me to use as int? Yes, you can use it. So then what is the difference between this int and this int? That we'll discuss. Okay, and function call a swap of a comma b. So this is your function call, and fun swap is going to be a name of function, and a comma b is going to be your arguments. In terms of definition we are defining the task. Body of the function is called as function definition. Actual arguments are used with the function call, and formal arguments we are using with function definition. Return, I'll tell you with an example. So what is the default return value of a function? It is int. So remember this point clearly. So default return type for a function is integer. That is okay. One more thing. So here I'm using as void add. Here also we are using as void add. So why here we are not using as void add? Okay, that is here I'm declaring as int a. Only once I'm declaring inside the main. Again, in all the places I'm directly using as a or b, not int a. Similarly, first time I'm declaring as add is the with return type void. So inside the same function I can directly access add. I don't want to go with void add. Just similar to int a is only declared, I'm using only a throughout this main function. Okay, hope you understood this example clearly. Then what does we'll try to run the code better. Example 1.c. So I think there is a problem with formatting issue as we are copying from the content from PowerPoint. So let us write the code. Okay, so I'm going to declare the variables called a as well as b, and how to read the input with the help of normal basic input output. So enter two numbers or a comma b, whatever you want you can give it. So scanf percentage d, so ampersand a and ampersand b. So normally we used to print the addition of two numbers as printf, like sum as percentage d comma a plus b, or c equal to a plus something like we can give it, right? I can go with your traditional format itself, like c equal to a plus b is a declare c before, right? So now I'm going to use the functions. So along with the variable, I'm going to declare the function also. Return type as void and function name as add. So which can take any two integers. So I'm giving as int comma int, centralized format I'm giving. Okay, fine. Void add of int comma int. Okay, and I'm reading the input. After that, I'm going to call the function call add of a comma b. So outside of main, we are going to declare it void add of, and I'm passing two integer. So I receive into other two integers. It may be a b or xy. Int x comma int y. So what does I can declare a variable called c and c equal to a plus b. We are going to print c. Save the code. And what is our program name? He gave us example1.c. So gcc example1.c is undeclared. Size. Okay, because here we are using xy, right? So it should be accessible as well. Because in main only the variables are named by ab, and we are copying ab into xy. So you can't use ab anymore because ab is local to main function, xy is local to add function, right? So both will be with different memory location. Okay, fine. There is no error. I'm going to run the code. So enter ab, we are giving us 10 as well as 20. So sum is 30, we have got it. Okay. See, in this, whether this should be x and y, no, you can give any variable. If I'm giving as a as well as b, what will happen? So you can, so here also is it uses a plus b. So in this context, whether this ab and this ab is same, no, it is different. Because this AB is local to main function, this will have a different memory address, and this AB is local to add, which will have a different memory address. Okay, so let me check again the same thing. So we have got it. Okay, so the variable's name can be anything. Only constraint is you should pass two integers here. If I'm passing one integer, one float, it will not accept, since we are declaring that this function will take two integer. For example, if I need a function which takes two float, what should I do? I should give us float comma float. So like that we have to change it. So why I'm using as void here? I'm not going to return anything. So I'm using as void. Suppose if I want to return something, what should I do? I should mention what type of data we are going to return, because here we gave us int main, right? So which means what, this function should return one integer variable, but we have nothing to return in terms of main, so we are giving return 0. As we are giving as main int, it is compulsory to return one integer. If we have nothing to return, we can go with return 0. For example, okay, how the flow of this code will be. And you know that in all the programming languages, the program execution will start from main function. So it will start from main, it will declare AB, it will declare a function called add, it reads A as well as B, and it will call the function called add of. So after this, the control will directly go to function definition. You know that this is going to be a function call. So for function, I'm shortly writing as fn. So whenever you are calling a function, it will go to function definition. So this is going to be a function definition. You know that only once we are going to define the function, and we can call it for n number of times. Okay. So after this, the control will come back to wherever it is called, and it will go with the next statement. For example, we'll test it better. So printf, I'm printing as before function call. I'll go with formatting itself, slash n and all. Sorry, this slash, right? Before function call. Okay, here I'm giving is slash n after function call. See, what we are telling is it will print before function call, then it will go back to function definition. After that, the control will come to this print on this place, then it will go to printf. We'll check. Okay. So what is the function name? Example1.c, gcc space example1.c. Okay. So enter ab. See, this line is executed, right? Enter ab, and we are giving inputs for ab. Okay, we are giving 10 as well as 20. That is for scanf we gave input. Then so the first thing is it is printing as before function call, that is before function call. Then it is going to function definition, so it is performing the addition of a and b. It is printing the output as sum as so and so. It is printing that output. After that, the control is coming back to this place. Again is going to next line and printing the output as after function call. We have after function call here. So hope you understood how the function call is happening, right? Okay, and here I'm telling we are using as void since there is nothing to return. If I want to return something, what we should do? Basically, what is return? You take a simple analogy. You just forgot all the technical terms and all, and you know that every task can be a code module, right? For example, we are taking two different tasks. You are asking me permission to go for drinking water. Second task is I'm sending you for taking a book. So what is your first task? I'm asking you to go for a water. Second task is I'm sending you for. Okay, in the first example, you are going for drinking your water. So you are not going to return anything. Simply you will go there, you will finish your task and come back. So you are not going to return anything to me. In the second case, I'm asking you to get a book. So I will be waiting for your reply. So either you have to return the book, or you should say that the book is not available. Something you are supposed to return to me, it is compulsory. So you have no option for skipping it, right? Similarly, so if you take void, because that is nothing. These kind of functions we are using, you will go there, you will perform your task and come back. You will not return anything to the place wherever it is called. But in terms of return, okay, I'll convert the same example into return. We are using as int. So which means what? This function should return one integer variable. So where else we should change this? Here also we should give us int. Okay, better I'll cut all the extra stuffs so not to confuse you. Okay. So here I'm telling that this is function declaration, right? I'm telling there is a function called add which take two integer arguments and which returns one integer. So we are calling as add of a comma b. So when you call as add of a comma b, it is going to call this, excuse me, it is going to call this function. At the end it should return something. For return we should go for the keyword called return. So it is compulsory to return something. If you have nothing to return, you can give us return 0 also if you have nothing to return. So here what we are planning is we are performing the task here and we are returning the output, return C. I'm going to return the output here actually. So when we call this function, it returns something. What it is returning? One integer variable. So where to store an integer variable into another variable, right? This may be C or sum also, whatever we want. So what is sum? So add of a comma b will return one integer variable that I'm going to store into a variable called sum. So sum should be declared before. You know that all the variables should be declared before. The same rule applies for functions also. So I'm declaring a variable called sum, and sum will show the return value of it. So I can print the output here, that is printf. So within double quote sum is percentage d again sum. Okay, fine. Right. We will save this code. So okay, one more thing. Here also we are using int. Here also we are using int, right? What is the difference between this int and this int? So this is this implies the type of data we are going to it is going to pass, and this is type of data it returns. This int is the data type and this int is going to be a return type. So this specifies what type of data we are going to hold, and this specifies what type of data it is going to return, right? So how this flow will work? Again, execution starts from main function. So we are declaring variables a, b and sum, and declaring a function called add of. Here we are going to pass, we read two inputs, and you know that the associativity of equal to operators from right to left. What is the associativity? I'll recall the concept again. See, listen. If we are giving us a plus b, so plus is the operator. Consider the statement a plus b and a equal to b. So in terms of a plus b, what will happen? It will add a with b. A with b. So the associativity of plus is from left to right. This is left to right. But in terms of a equal to b, what will happen? We are assigning b to a. So the associativity of equal to operators from right to left. First it will take the right side, then it will go to left side. Okay, come to it. Hope you remember this. So here we have equal to operator, so it will go, if it will focus the right hand side first, then it will go to left hand side. So add of a comma b will call the function, and we are defining it. So add of a will go to a and b will go to b, and it will calculate a plus b and store it into c and return c. Why we are giving as return? Since we gave as integer, so it should return one integer variable. If we are using as void, there's nothing to return actually, because void with the return will not work. So as we gave int, we are going to return one integer that we are storing into a sum. If we want to return a float, what should we do? Float add of, and here also we should give us float, and we should return one floating point variable. So this is an example which will tell you how to return something with the help of functions. We'll go back to PPT again. Hope you are following it. Okay. We were talking about return type, arguments and all the things there, right? Based on that, we can go for 4 different types of function prototypes. That depends on return type and argument list, right? The first one, the function with no argument and no return value, with no argument with return value, with argument no return value, with argument and with return value, because these are classified only based on the arguments and return value. Either we can have arguments or we may not have arguments. Either we can return something or no need to go for returning something, right? So okay, so what is return, what is with arguments, that you know, right? You can compare that general analogy itself. There are some tasks you should return something. There are few tasks, some tasks you can go and perform the task and come back. Okay, let me start with the no argument, no return value. So better to consider this example, and I'm taking the addition of two numbers example for all these scenarios. So let us go for the first one. So the first one, no return value and no argument. So how to declare? Void add of. So what is void? Return type. And where to declare a function? Anywhere, before main or inside main. The constraint, before you start using, you should declare it. That is the rule for it actually. Okay. Void add of. What is void? It is return type. What is add? Name of the function. We have no argument inside though. No return type, no argument. So what is the task? I'm going to perform addition of two numbers with all the four scenarios right now. So add off. So we are going to call the function, right? And the function, the control will go to, this is function definition, function declaration, function call, function definition. So the control will take us to a function definition. It will finish the task. Again the control will come back here and go to the next statement. The control will come back, it will not return anything actually, right? After this, okay, the arrow should come here. So after you complete this task, again the control will come back to the main, right? Go through this example. Reduce the font so that you can understand something better. Okay, before main or inside main you can declare add off. So this is function declaration. Here we are going to call the function called add off. So it will go to function definition. See, I'm not give, I can't pass any arguments into it, right? Since this is no return type. So I need input to perform the task. So we are reading input, and instead of reading I'm assigning it. So with the, instead of giving a scanf printf, I'm going for a fixed value. So here I'm getting the input, I'm performing the addition of two numbers, I'm printing it. Again the control will back to this position. So as there is no arguments, I'm calling as empty. As it can't return anything, I'm using as while. So here there is no argument, here also there is no argument. If I have two arguments here, and I should receive that with two arguments, else it will not work. Hope you can understand this. This is one scenario, and actually what we are going to do is we are going to learn all the four scenarios with a simple example. Then depends on the application, we can select the scenario and we can work when you work with the programs. So first we are going to learn all the four scenarios available with some basic example. So then depends on the application, you can decide what type of function prototype we need to choose. So go through this code. Hope you understood. Yes. So we are moving to next one, function with no argument and with return value. That is, we have no arguments, so this is empty, with return type, and I'm taking as int. The return type may be int or float or any data type, and for our convenience we are taking as int. So this is int return type, function name, no arguments. So as we have no arguments, you can't pass anything, right? So for input we can read and process here itself. So add off. So we are going to call it, and the control will go to function call. It will finish that. It returns something. The returned value is stored in terms of sum. So what type of data type sum should be? Again, it is also it should be an integer, since we are returning one integer from here, and this is also should be an integer variable. You can go to it. So int add off, function declaration, and you can declare inside main also, right? As I told you before. And add off will go to function definition. So instead of using scanf printf, I'm assigning, because I wanted to make it a simple code. So it will perform addition of returns. Either you can give us return bracket C, or you can give us return space C. Both will work actually. So return C, and it will return, it will come back to this statement. So sum equal to C, it will replace the code as sum equal to 30, so that it will print the output as 30. Okay, let's go through this code. Okay, so we move to the next thing. Yes, function with argument and no return value. Function with argument and no return value. So what will happen? We are passing arguments. As you can't return anything into it, you can complete your printing there itself. If you have an option to return something, you can return and you can print it. As you have, if you have no option for printing it, you can finish your printing task in function definition itself. But one more thing, okay, we'll go to the next example better. See what is happening here. Let me reduce the font. Okay, and we are declaring a function called add with two integers and with returns nothing. So a equal 10, b equal to 20, add of a comma b, and here we are going to call the function. We are performing the task and printing here itself. See, what is the difference between the previous code and this code? Previously, we are not passing any argument from main. So you read or you assign the input with the add function, then you are using it. But here you have the option for passing the input from main, then you can pass it and we can use it. So int c is equal to a plus b, then we are printing it. Okay. Okay. So if I want to return C from here, what to do? You can't do it because you gave return type as void. If you want to return something, the return type should be the corresponding data type. So here it is with arguments with no return type. So you have the option to pass the argument, but you have no option to return something. So you will finish everything from here and returns nothing. So only the control will come back to this position. Fine, super. Okay, then we go with function with argument and with return value. See to it. So you have the arguments and return value also. You know the difference between this int and this int, right? This is what data type, which specifies what type of data it holds, and this specifies return type, which means what type of data the function is going to return, and make the difference very clearly. So here add of a comma b, we are calling the function with arguments, and you will finish your task, you will return something into it. The returned value will be stored and used. So if we are using return, that will be stored in access. If we are using as void, only the control will come back here, it will not return anything. We go through this example. So add of int comma int, and as we can pass arguments, either you can assign or read using scanf printf. You are going to pass it, and inside that you are going to perform the task and return the output here. For example, okay, if I want to print C here itself, what should I do? I can give as printf %d comma c. In such case, if I'm not using return, will it work? No, it will not work. So I'm telling you, so print the output here itself. Then what you will do? Yes, you will print it here, and you can give us return 0. Right? Okay. So these are the 4 function prototype, and based on better you practice one simple example. You take addition of 2 numbers or area of a circle or any simple application. You can convert it into 4 different options like function with argument, with return value, and all the 4 products you can practice. Then you will have a clear idea about how to work. Then depends on the application, you can decide the type of function declaration we need. Okay, hope you are okay. We'll practice one or 2 examples better. What example we can? Okay, we'll go with the area of circle. So I'll go with the area of a circle with a different thing, right? I'll take any two scenarios. Because area will return in terms of decimal, right? Float area of, okay, for area, what is the input we need? Radius, right? So I'm giving as int rr radius. Float area of, okay, first I'll go with void area of int, that is first time I'm telling I'll give you my input, you process and print the output and come back. So that is what return type as void. Area is the name of the function, and int is going to be a type of data we are going to pass. And where is the value for radius? You should read it. How to read it? With the normal methods, printf enter radius. Okay, you can use /n also, right? And then scanf %d %radius. Then how to call the function? Area of, what input we are going to pass? Only one integer it is allowed, it is a radius. Okay, and outside of main I'm going to declare. Whether it should be only with inside main? No, it can be before main also, right? how to define it? Void area of, how many inputs we are passing? Only input, only one. What type of input? Integer. So it should be int. The variable name can be anything, right? Int or array. Okay. How to calculate area? I need a variable here, right? Int ar or anything, and ar equal to what? 3.14 star r star r. So we have calculated areas in terms of ar. We are going to print it. Print of areas percentage f, and ar should be float, right? You can use integer also, round off and print it. There's no constraint for this. Comma ar. Okay. Check the code once, and we are declaring as area. I'm reading one input, then we are passing it. As we are giving as return type as void, nothing has to be returned. Example 2, right? Clear screen. GCC example 2.c. Okay, fine. Area I'm giving is 5 and area 75 points, so on and so forth. Okay, this is one example. And what is the task? What here we are planning? So we are reading input and we are passing it into a function. That function will process everything and print there itself, right? So what method it is? Function with no return type with argument. So function with argument with no return type. So how many arguments we are using? It is only one. In the previous example we have used 2 arguments. Here we are using as only one. So you obviously it depends on the type of application, right? And this is one example. Okay, one more example. If I want to return the output, so here, okay, if I want to return the output, so what should we do? And I should change the declaration as float, since it is going to return one floating point. As it is going to return one floating point variable, that should be stored into another variable. So I can give us a. What is a? A should be a floating point variable. As it is, that area of radius will return one floating point variable that can be stored into another variable called a. So a is also should be float. Again, here we can give us float. So as we are giving something as return, we should use the keyword called return, because without return keyword you can't return anything, right? So return, what we are going to return? We can return the output itself, right? Yeah. So instead of printing here, we can print the output in the main function. So here it will read the input in terms of r excuse me. So it will calculate the area of circle. It returns er as the output. So ar will, so this code will become as a equal to ar. So now we have the output in terms of a. So we can print the same a as it is. Got it? We are, so how does it works actually? It reads radius, and area of radius will call this function. It will process the area of a circle and return the code as a equal to er. So a, and this output will be stored in terms of a that we are printing here. Save the code and go to it. So example 2.c, again the same, enter radius, and we are getting the output as same as I'm giving same input. What is the difference? In the previous code we were not returning anything. Here we were returning one floating point variable. So like that, depends on the application, you can decide what type of prototype we need to use. So better practice with simple example for all the types, right? So this is about your different function prototype. Okay, there is the next topic is parameter passing. So parameter passing, there are 2 classifications we have: pass by value or call by value, and pass by reference or call by reference, which can be named as pass by value or call by value also. So pass by reference we can't see now, because pass by reference needs something called pointers. So pointers we didn't learn so far. So I'll tell you what is pass by value, because we are passing an argument from actual argument to formal arguments, right? So that is called as parameter passing. So the default mechanism of argument passing is pass by value. Because so far we have discussed something, area of circle, addition of 2 numbers and all the things, right? In all, the default mechanism of parameter passing is pass by value. So in that, what is happening is we are going to copy the content from actual arguments into formal arguments. So and formal arguments, you know that this dummy arguments, right? So formal arguments are photocopies of actual arguments. So because you know that you are going to copy the content from actual arguments into a formal argument. After that, there is no relationship between actual and formal. All the operations you are going to do only with formal arguments alone. So we are going to say that actual arguments are independent with formal argument. What is that independent? I'll tell you with an example. Wait. So we'll see one more example now. Swapping of two numbers using call by value. Okay, I would like to recall one thing. In so far we have discussed so many examples for parameter. Passing and returning something. All the things will come into a category called call by value. Now we go swapping of two numbers. So that I'm declaring two variables called a as well as b. I'm declaring one more function called swap. So void swap of int comma int, which means what? You know that this is coming under the category of function with arguments and with no return type. So I'm telling that there is a function called swap which take two integer arguments which returns nothing. And we are reading value for ab, and I'm going to call the function called swap. So swap of a comma b, which will call the function, right? And I'm going to close the main with return 0. So how to define the function? Yes, return type, function name, then argument list, right? So void swap of int x comma y. And what is ab and what is xy? Ab are actual arguments, xy are formal arguments, and ab will have a separate memory address and which is controlled by main, and xy will have a separate memory address which is inside swap. So we are going to print xy before swap, and we are going to write the code for swapping. Then we are going to print after swap, and we are using t for temporary variable for swapping. So we are closing it, right? So how the flow will work actually? So it will start from main, it will read ab, and ab will be passed to swap function, and a will go to x and b will go to y. So we will swap it. So what about what is the actual value of AB if my input is 1020? AB will have 1020. What about XY? XY will receive will go with an example. I hope this screen is clear for you. See, in main we have AB, in swap we have XY. Just see step by step. In main we have AB, in swap we have XY. So say for example the address of AB is going to be 2002, this is random address 2000 2004, and XY is 4000 4000 and 4004. You know that AB will have a different memory address and XY will have a different memory address, right? Okay, if my input is 1020 for AB, what A will have 10, what B will have 20, right? So what we are doing here, we are going to copy A to X and B to Y. So A will go to X and B will go to Y. Now AB is 1020, XY is also 1020. You know that AB and XY are with a different memory address, right? Okay, where we are applying swapping actually, we are swapping only XY, right? So this XY will be swapped by 1020 to 2010. So now XY will have 20 as well as 10. What about AB? AB remains same because we are doing all the tasks only with formal arguments. We are not disturbing actual arguments anymore, right? So once you take a photocopy from this, all the corrections and all the things we are doing only with formal argument, actual arguments are remain same. So this is the concept of call by value. You are going to take the photocopy from actual argument to formal argument, and for formal arguments are photocopies of actual argument, and all the tasks we are going to do only with formal arguments alone. We are not disturbing actual argument, so that we are telling that actual arguments are independent with formal argument, which means the changes whatever we are doing with formal arguments will not be reflected with actual arguments. Alright, so this is the concept of call by value. Later we will try to print. We'll check if it works because we are copying from example 1. Okay, fine, it is working, the formatting is right. Okay. So AB we are giving us 10 as well as 20, before swap 1020 and after swap is 2010. Let me clearly run the code better. I can cut, because what is the need for using these command line actually, because these command lines will increase the readability of code. So it is advisable to write the programs using command line. So to increase the readability of code, you go for command line, but here it will confuse us little. So I'm going to cut. Okay. Okay. So here we are reading AB and we are going to pass it, and then here we are going to swap and print it, right? Okay, if you print AB here, what will happen? How to print it? Printf. I'm not going for any formatting, that I'm giving %d, but I'll go with new line slash n. In new line I'm printing A comma B. Okay. So you know that the previous output says before swap 1020, after swap 2010. Which means what? Before swap we are printing xy and we are going to swap. Then you are printing xy. After swap we are printing it. So what I'm going to test it. I'm going to read the input. I'm going to print AB first. Then I'm calling a swap function. And after perform this task, I'm going to print AB just to check whether AB is same or it got swapped. That's it. I'm going to clear the screen. Let me reduce the size of it. This is space example 1.c. Okay. AB I'm giving a same 1020. See what is happening. Okay, what is this AB 1020? This is the code for this, right? Scanf. And we are printing AB. What it is printing? 1020. Then swap of A comma B, it will go here, right? Here we are printing before swap. What is before swap? The same 1020. And it is swapping the code after swap 2010. That is xy got changed from 1020 to 2010. So after this the control will come back to this place, right? Again you are going with next, you are printing AB. So AB is again 1020. So before function call also it is 1020, after function call also it is 1020. What happened to that swapping part? Because the swapping is only with formal arguments alone. It is not disturbing the actual arguments, right? So because as AB and XY are following a different memory address, what are the changes you did with formal will not be reflected with your actual arguments. Then what should I do if I want to disturb this also? If I want to if I want to swap AB with the help of this function definition, what should we do? Then we need something called pointer that we'll discuss in the next topic. That is achieved with the help of pass by reference or call by reference. So as of now, with the concept default mechanism of parameter passing is going to be call by value, and in that actual arguments are independent with formal arguments. If I want to change the actual argument, if formal arguments change, I have to go with the concept called call by reference. Call by reference we'll see in the next class. Next PPTs, right? After pointers we will discuss the concept of pass by reference. So let me conclude this topic. So far we have discussed something called functions with library function and predefined function, and 4 different function prototype and partial parameter passing methods we have learned. So without functions you can't write any code with any programming language. So have some clear understanding of functions, practice 2-3 programs with your own choice, and then only you can understand the concepts. So we'll see in the next part of functions. Thank you.